Well, hey everyone, we are moving along through chapter 9. Today we're going to start to think of a different way in which to solve a quadratic. We've used the roots method. We have used factoring so far, but sometimes problems can't factor, or maybe we need to put them in a certain form. So we manipulate them to put them in a form that is easier for us to solve. And we like to call this by completing the square. The whole process of this is so that we're going to set it up in a way that it looks like section 9.3, where we use the roots method to solve these, where we have something squared equals a number and we take the square root of both sides. Let's start to see how this works, okay? So as we look at this, there's just a couple of things we have to look at. Number one, we need to make sure that A is equal to 1, and we want to move C to the other side of the equal sign. I want to actually take this out of standard form. It needs to not be in standard form. The constant needs to be on the other side of the equal sign. So we'll end up leaving a space where the constant used to be. Well, the purpose of that is because we're going to put something in its place. We're going to create a perfect square. We're going to complete a perfect square. So by solving using this method, we're going to add a number to both sides that completes the square, which is actually part of our homework, just finding this number, step 2. We're going to take b, we divide b by 2, and we square it. That is the number that we're adding to both sides. And by doing this, we're actually creating a special case factoring that we did in the last chapter. And you'll see how this works. This allows us to solve by using the roots method, and we get a nice, simple answer most of the time. Okay, let's look at this first one. So when we go to look at this first example here, right, we have x squared plus 6x plus 8. We look, number one, a is 1, so that's in our favor. We already got that going for us. And 8 is not on the right side, so we want to take this out of standard form. We're just going to move 8 over, so we subtract 8. For both sides, and like that we end up with this new equation. Now our goal is we have to figure out what are we going to do here. We need to fill this in with something that is going to create or complete this perfect square trinomial. How do we do that? Okay, that is step 2. We take b, we divide b by 2, and then we're going to square the whole thing. Okay, this needs to be our side work on this side, a little bit of side work. So 6 is b. We take 6 divided by 2, and we're going to square it. So that's 3 squared equals 9. This is a nice perfect square. We are adding 9. If we add 9 to one side, we have to do it to the other. Okay, the whole purpose, the reason why we did this, I like to tell the kids in class, you put all the ingredients together to make a chocolate cake, you put it in the oven, and what comes out of the oven? Well, hopefully it better be a chocolate cake. That's what we just did here. We took all the ingredients that we needed to create this perfect square trinomial for only one purpose, and that purpose was so that we could do a special case factoring. Right? We take the square root of the first term, which is an x. We take the sign of the middle term. Each term is contributing something to this factoring process. And we take the square root of the last term, which is 3, and it gives us this nice squared binomial. We did it on purpose. That's why we did what we did. So the whole purpose of this is to get that form, that perfect square trinomial that can factor into a binomial squared. Equals, well, this cleans up to be 1. Now, this is right where we were at before in 9.2. This is the roots method. How do we solve this? Well, we're trying to get the x out. The x is trapped in a set of parentheses and it's squared. To remove this square, we have to take the square root of it. Which means on this side, we have to take plus or minus the square root of this side. And it just so happens this is a nice perfect square. The square root of 1 is 1. So we have plus or minus 1 is equal to, well, this canceled the square root. We're left with an x plus 3. Almost done. We have to solve this now. Subtract 3 from both sides. X is equal to negative 3 plus or minus 1. We can break that into two parts. We have -3 plus 1, -3 minus 1. So here are our solutions, -4 and -2. Those are the solutions for this problem when we used it by completing the square. What number was added to both sides to complete the square? 9. That was 6 divided by 2 squared, or b divided by 2 squared. Okay, look at another example. Wow, look at this one. Here we go. Look, A is already 1. That is exactly what we were looking for. A is 1, but we need to move this C. I want to move this to this side. Okay, when I do that, I now have the new equation is x squared plus 12x, leave a space, equals -34. Now we have to fill this in. This is part of the number that we have to add to both sides to help complete our square. We take b, we divide by 2, we're going to square it. Okay, so b was 12 divided by 2 squared. That's 6 squared, which gives us 36. This is our side work. If I add 36 to one side, I have to add 36 to this side. This gives me a 2 left on this side. And this, again, the whole reason why we did it is so that we could factor it into this perfect square trinomial. Snatch the sign from the middle. Take the square root of the first term. Square root of the second term. And like that, we have something that's easy to solve. Now this one, you want to leave it in simplest form. Leave it in radical form, which is its simplest form. So notice we're going to take the square root of this side. These cancel. Plus or minus square root of this side. And the square root of 2 is not a perfect square. We don't want to mess with a decimal right now. So I'm just going to leave it as plus or minus square root of 2. Okay, in order to solve this, we subtract 6. Cancel, so we're left with x equals, and in an exact form, simplest form, radical form, you have -6 plus or minus square root of 2. And like that, you are done. That is 2 separate answers right here. You have -6 plus the square root of 2 and -6 minus the square root of 2. Now we're going to bring it all together in the last one. This one, we want to round to 2 decimal spots for our answer. So we need an exact answer-ish because we have to round. So, but we're rounding to 2 decimal spots in the end. That's telling us we're going to have something that's probably a radical that isn't like a nice, pretty number, but we're going to have to work with it in our calculators. Okay, first off, A. A is not 1, so we have to divide each piece by 4. Right, we're left with x squared minus 2x minus 6 equals 0. I want to move this over to this side. So add 6 to both sides. I'm left with an x squared minus 2x, leave the space, equals 6. Those canceled for us. Here we go. We need b divided by 2 squared. And don't be fooled. This is going to be a whole section of our homework. They just want to know what number do you have to add to both sides to complete the square. Have b, 2, -2, divided by 2 squared. It's -1 squared, which is 1. And the whole purpose, again, was so we could factor. Special case factoring, rob the sign of the middle term. Square root of the last. And right like that, you're ready to finish your solving. Take the square root That cancels, leaves us with x minus 1 equals plus or minus the square root of 7. That is not a perfect square. Leave it the heck alone for right now. And then we have to add 1 to both sides. So here we go. We're getting this. Here's one answer. 1 plus the square root of 7. 1 minus the square root of 7. And you have to be careful, guys. We have to put this in our calculators. And it is so important. You have to type 1, the number 1, plus 7. You hit the square root button and make sure you hit the equals button. You end up with something that looks like this, which is 3.645, and it keeps going. Right? This 5, round to the hundredth. This 5 is telling you to round the 4 up. So your answer is 3.65 after you round it. That is your rounded completed answer. Now on this side, in your calculator, you type 1 minus 7 square root, and you have to hit the equals button, and you get a negative 1.65 once you round it up. So because, again, please be careful, guys. This was actually negative 1.645. 5 told you to round it up. These are your solutions after they're fully rounded to the nearest hundredth. You have to be careful. You have to practice the calculator. You got to start getting good at this, all right? Get out there and get that homework done.